Okay, so the next step after we can figure out the state is now to find the property. And so we're going to add the skill that we just learned or we just practiced, and now we're going to go a little bit further. So again, in this section, I'm looking at H2O, specifically water in everything. And it tells me I want to find the property, and I want to locate the sketch on a TV diagram. So here's what I have. For my temperature is equal to 140 degrees Celsius. My specific volume is equal to 0.5. I want to find pressure in bars. That's what I want to find. Okay, so the first thing I want to do here is I want to set the state. I want to figure out liquid vapor mixture. That's what I always want to do, and I'm going to do the same thing repeatedly. And they asked me to do it on a TV diagram, so I'm going to draw a TV diagram. And here you're thinking, okay, they asked me to draw a TV diagram, but they didn't give me a nice pressure. So I'm looking for a pressure here. And since I don't know what the pressure is, since they gave me the temperature, I'm going to put this temperature here. I'm going to put the temperature as the saturation temperature. I'm going to say, well, at 140 degrees Celsius, what is my saturation pressure for that? Okay, so I'm going to go to my document camera here, and let's go look at 140 degrees Celsius. All right, 140 degrees Celsius. We're going to saturate at 3.613. Okay, bars. Well, that's great and all, but that doesn't tell us anything, because the two things that we were looking for, we were given here, are temperature and specific volume. So what I now want to figure out is where are saturated liquid and saturated vapor on this. And so now I hope you have this hope you have this pulled up yourself. Okay, so I'm now going to go over here, and I'm going to go read off the values of what is my specific volume saturated liquid and what is my specific volume for a saturated vapor. And so my value for the first one is going to be 1.0797, and I have to remember this up here, it says times 10 to the third, so this is going to be times 10 to the minus third, and my second entry here is going to be at 140, 0.5089. Okay, so I know that at this temperature, I am going to find out where saturation occurs. That's always what I want to do. And saturation is going to be between a specific volume of 0.0010797 and 0.5089. It gave me a value of 0.05, which is really darn close to being a saturated vapor, but it's not there. It's right here. This is my point. And so I know that I am going to be saturated. Okay, so the first thing I know is this is a liquid vapor mixture. Okay, that's the first thing I know. The second thing to ask me is what is the pressure in bars, and that means that the pressure is going to be equal to 3.613 bars. Okay, because I am between those two values at that pressure. It's got what it's got to be. It's what it's got to be. So that's the answer to that question. Okay, there is a lot of different ways that we can find the properties. But I am going to emphasize, to start off with, always understand where saturation is and if you're above saturation or below saturation. And if you do that, I think it'll start giving you the skills that you need so that maybe you can skip some steps later on and say, oh, I think it's already a liquid, or oh, I think it's already a vapor. But right now, always go to saturation. I can't emphasize that enough. Okay, let's go look here now at B. At B here, they say now our pressure is equal to 30 megapascals and our temperature is equal to 100 degrees Celsius, and they want us to find specific volume in meters cubed per kilogram. Okay, so let's figure out what's going on here. We're going to draw ourselves, we could draw ourselves either one, the PV or TV diagram. I'm going to draw the TV. I would ask you to maybe draw the PV and see if you get the same thing when you're working on this. So if we do a TV diagram, and we work with this, we're going to find that, whoops, my microphone came in the way here. Microphone, get out of the way. We are going to draw a vapor dome, and we're going to draw a line of constant pressure that is 30 megapascals. But our tables are not in megapascals, they're in bars. So you need to remember it. If you don't remember, up here in the very top corner it says 1 bar is equal to 0.1 megapascals. This is going to be equal to 300 bars. Okay, so you want to put things in Celsius in bars here. So 300 bars. Now, I'm not telling you here that 300 bars is where it saturates is 100 degrees Celsius. That's not true. So I'm going to have to go find out with 300 bars, where do I saturate? Okay, so 300 bars, pressure bars, pressure. Going on here. Oh no, we have a problem here. We have a problem. There is not a 300 bar entry. Okay. Okay. There's not 300 bar entry. A lot of people say automatically, well, it's too high, it's above this, it's got to be a vapor. Okay, that's not actually true in this case, and let's prove why that's not true. Let's go here and figure out what it would be on a PV diagram. We draw the same thing, and now we're drawing 100 degrees Celsius. Let's see if 100 degrees Celsius is on our table. So 100 degrees Celsius. 100 degrees Celsius is on our table, and it says here that we saturate at 1.014. Okay, 1.014. That's how many bars we saturate at. Where are we? Man, we're way up here. 300 bars. We're way up here. So where would we intersect with this line? Way over here in the liquid state. Okay, way over here in the liquid state. All right, so what do we do? Well, we are going to have to now go to our liquid tables. Table A4 is going to be superheated water vapor, so that's not where we want to go. We want to go to table A5, properties of compressed liquid water. And we have a whole bunch of pressures here: 25 bars, 50 bars, 75 bars, 100 bars, 150, 200, all the way down here, 300 bars. And there is an entry for 300 bars, 100 degrees Celsius, and that entry is my specific volume, is going to be 1.0290 times 10 to the minus third meters cubed per kilogram. That's what this problem is telling us. But we didn't know which table to go to, liquids or vapors, or liquid vapor mixture, until we found that saturation point. Now, if you're asking me the question, how would I draw this on a TV diagram? Well, that's a good question. How do we draw this on a TV diagram? Okay, on a TV diagram, I might do something differently. I might write it this way. I might say, well, we know at 100 degrees Celsius, we're going to saturate here at what we say 1.014. And now our pressure line that we're actually going to be dealing with is way up here. It's a pressure line that doesn't even go through the vapor dome. Okay, why isn't it on the tables? Because at 300 megapascals, or 300 bars, 30 megapascals, we don't go through the vapor dome. We are above the vapor dome, and so we're going to flash here from a liquid to a vapor right at that point. Okay, and so we could also look, and another thing that we could point out here in our table A1. Table A1, when we're looking up water, alphabetically down here, water, it has a critical pressure of 220.9. We're at 300 bars. We're well above that critical point. Okay, so what we would say is we're over here. This is where we're intersecting. This is our point that we're looking at. This is the point we're looking at here. 100 degrees Celsius, 30 megapascals. But remember, if it's not on the table, it means it's above the values. It is not there. We are not getting anything. We don't have anything to put in this table because we put saturated liquid and saturated vapor in this table. There is no such a thing as a saturated liquid or saturated vapor for 300 bars. So that's what we need to understand for this problem. Okay, but it did tell us which table to look under. All right, I am going to do problem here, C, and then we'll move on and give you a problem to do for your lecture quiz. Okay, that is going to be temperature is equal to 80 degrees Celsius, and they tell us the quality is equal to 0.75, and they want to know pressure in bars, and they want to know specific volume in meters cubed per kilogram. Okay, they want to know two things. Well, number one, when they gave us this, they already told us what the state was. We know it's a liquid vapor. If they give us a quality, it has to be. It has to be a liquid vapor. So that's what we know. So what I'm going to do here, and I can go ahead and draw this on a TV diagram. TV diagram. We're going to be looking at 80 degrees Celsius, and we're going to be looking at here about 0.75 for my quality. Okay, so what I want to find out for 80 degrees Celsius, I want to find out what is my saturation pressure. I want to find out what Psat is. So, 80 degrees Celsius. 80 degrees Celsius, Psat 0.4739. Okay, that's going to be my pressure in bars. I'm just going to put the bars here. That's going to be my answer there. Now, I also want to find out what VF is. So VF is going to be equal to 1.0291 times 10 to the minus third, and VG is going to be equal to 3.407, and this is both going to be meters cubed per kilogram. Okay, and so to find out what my specific volume is, it's going to be VF plus X times VG minus VF. We got to do a calculation using the quality equation that we derived in our last lecture. So the specific volume is going to be 1.0291 times 10 to the minus third plus 0.75 times 3.407 minus 1.0291 times 10 to the minus third. Okay. And this gives me that my specific volume is going to be equal to 2.556 meters cubed per kilogram. Okay, which makes sense. It should be closer to 3.407, and it is. Okay. Conversely, what I could have given you is I could have given you the specific volume was 2.556, and then you find out what the quality is. That's another way I could ask this question. Okay, so another type of problem that we will deal with. Okay, for your lecture quiz question, here is what you need to do. You need to find out at a pressure is equal to 10 megapascals, and my temperature is equal to 485 degrees Celsius. Find my specific volume in meters cubed per kilogram. Okay, so I'm going to start you on this, so that you have some effort here. So have some know what you're doing here. Okay, so what we're going to do here is we're going to draw our TV diagram, and I draw a nice line of constant pressure, and I'm going to say it's equal to 100 bars. Okay, 10 megapascal is 100 bars. All right, now I'm going to go to my pressure table, nice even pressures, and I'm going to go look for 100 bars. So here we are, pressure in bars, 100 bars. He says we're going to saturate at 311.1. Okay. What I have been given here in my problem is 485. So I'm well above here at 485. Intersects with it right here. That means I'm a vapor. Great, I'm a vapor. So now I can go to table A4, my superheated water vapor. And I'm going to be looking for 100 bars. Okay? And 100 bars is on page A11. 100 bars. It says here 100 bars, 10 megapascals. It shows us the conversion that we have here. 100 bars, 10 megapascals. It also tells us what the saturation pressure is here, so we don't have to really go look that up at our saturation charts if we didn't want to. Okay, but we are going to be going to look for where are we if we are going to be. Oh, I'm in a problem. I did the wrong thing here. I went too far. Properties of compressed liquid water. I went to the wrong thing. This is not the right thing, and I would have found that out because let's make this mistake. I made this mistake. I go here. I say, oh, there's no temperatures that are that high. What's going on? There's some sort of problem. That's what I immediately did. And I thought, oh yeah, I know what I did. I turned too far. This is a compressed liquid water table, so I have to go back to my other tables here, to my superheated water vapor tables, because this is what it is. This is a superheated vapor. Here we are. Here is 10 bar 100. Here is 100 bar 10 megapascal. Again, it tells me TSAT is 311.06. And now we go over here and we see there's some values here. Oh, 400, 440, 480, 520. But there isn't an entry for 485. There isn't an entry for 485. So what do I do? Well, I have to interpolate. I have to interpolate when I don't have a value that's exactly on the diagram. And so here we go. Let's start to interpolate. I'm going to say I have 480 and 520. And where I'm looking for a value that is 485. Okay, and let's look at what my specific volume is. My specific volume, they told me for 480, my specific volume is 0.04034. And for 520, it is 0.04313. And I don't know what this specific volume is. So how I'm going to do this, I'm going to assume it's a straight line between 480 and 520. We're going to assume it's a straight line between 480 and 520. So we're going to say rise over run. I'm going to say 0.0413, so sorry, 4313 minus 0.04034 is over, well, 4.4313 is 520. And 0.0434 is 480, is going to equal, I'm going to say specific volume minus 0. Let me see here, I did high minus low, so I'm going to do 0.04313 minus specific volume all over 520 minus 485, and I have my V is my unknown, which I want you to calculate, and that's going to be the answer for this. But note, I don't have to do it this way. I could have done 0.04034 minus 0.04313 divided by 480 minus 520 is equal to specific volume minus 0.04313 divided by 485 minus 520. I could have done that. I could have flipped them so that I had temperatures over specific volumes. In this last thing over here, instead of taking 520 minus 485, I could have been between 485 and 480 that I looked at this. There are 8 different ways to solve this, but they're all going to give you the same answer. You're looking at that slope of that line. So what I want you to do is I want you to draw this diagram that shows the slope of the line between 480 and 520 and our specific volumes here, and find out how you can visualize what that is and show this interpolation. Once you get this interpolation down, it's going to be no big deal. But until you get it down, there's might be some places where you're going to run into some trouble doing the interpolation. Okay, so we're going to do lots of interpolation this semester. So that's your top hat. I said top hat again. That is your quiz question for today. I know we got to 20 minutes here, but hopefully this has been helpful and that you have followed along with what we're asking for these problems.